Our next chapter is about solving inequalities, and actually the first 3 sections of it should be mostly review from previous classes, so I'm going to lump them all together. You can go through this video at your own pace. If it's new for you, then I recommend you go slowly. If you've done this before and it's easy, you can go through quickly. So we're going to start with a little bit about inequalities. And you may remember from previous classes that if you have something like this, this is said as x is less than 2. What that means is that x has to be a number that is lower than 2. So it can be 1, it can be -10, it can be 1.5, but it's less than 2. Or you sometimes will have something like this. You'll have y is greater than or equal to -1. What that means is that y can be -1. It can also be something bigger than that. It can be -1/2. It can be 0. It can be 12. Anything that's greater than or equal to -1. So I'm hoping that's review. The next thing that we have is a little bit about graphing inequalities. There are 2 ways to graph inequalities. The first type is graphing them in one variable, which will be on a number line. That's what we're going to do today. The second way that we're going to do in the future is going to be on a coordinate plane, which is on the XY axis. You'll be graphing a line in that case. That's going to be a little bit into the future. So when we're on a number line, the key thing that we remember is that if we have greater than or less than, you are going to have an open circle. And if you have greater than or equal to or less than or equal to, you're going to have a closed circle. So just don't forget those things. So let's start with an example. And we'll do 2 of them. My first example is x is less than or equal to 5. You're going to start by drawing your number line. So since we're working with 5, I'm actually going to put 5 in the very middle of my number line. I know you don't usually see it like that. You usually see 0 in the middle. But if you have it like that, it'll be a lot easier for you to draw. Because if you had something like x is less than or equal to 100, I would not want you to be drawing stuff all the way from -100 up to a +100. It would take you forever to draw that. So you can just start with the 5 in the middle in this case. Since it is less than or equal to, that means that it can be numbers like 4, it can be numbers like 3, it can be numbers like -20, but it's going to be only things that are less than 5, or it can also be equal to 5. To show that it can be equal to, we're going to use the closed circle, don't forget about that. And it's also going to show that we're going to use things that are less than 5, which means we're going to go to the left. So just make sure that you include numbers less than 5 and you also include 5. These are all of our possible solutions to x. We don't know what x is, and we actually can't figure out what it exactly is based on this problem, but we do know that it can be 5 and that it can be any number less than 5. Those are the 2 things that we know based on that. So go ahead, try this one on your own. So when you draw this number line, it's a little bit harder because it has negative numbers. I'm going to put the -2 in the middle. Now, don't forget, numbers to the right are going to be numbers that are greater than -2. -1 is greater than -2. 0 is. If you want to go further and add 1 to the right, you can do that also. We're also going to remember that -3, -4 are less than -2, so they're going to go to the left. Be very careful when you're drawing these number lines. The other thing we know is that it's an open circle. It can't equal -2, so we show that by showing an open circle. But y can be greater than -2. Numbers greater than -2 are things like 0, -1, 87, 5,000, anything positive, and also -1, 0, -1.5. So we're going to show that by drawing an arrow to the right. And that's our graph. So now let's go over a little bit with solving inequalities. If you remember in chapter 2, we did solving in equations, which was almost the same exact thing. The only difference with equations was that they always had an equal sign. Inequalities are going to have an inequality sign, the greater than, less than or equal to, greater than or equal to. But we're going to actually solve them just like equations. There is only going to be one little thing that we have to remember. And the one main thing is that if you multiply or divide both sides of your equation by a negative, you must reverse the inequality sign. So if you multiply or divide both sides of your inequality by a negative, reverse your inequality sign. That is the only thing that you need to remember. And then if you are good at equations, other than that, you should be pretty good at these. Reverse. So I'll show you some examples later on with these. That is really the key thing that you need to remember. And we'll do some easy examples first, and then we'll do some hard examples. And there's also a few in the middle. So for these examples, all I'm going to ask you to do is solve the inequality. You don't need to graph unless you really like graphing and you really want to do it. But for now, I just want you to solve. So my first one, I'm going to say this is number 3, because we did 2 graphs. My first one is n is less than, n minus 3 is less than or equal to 9. So you're going to solve this just like you solve an equation. You add 3 to both sides. You get n is less than or equal to 12. We didn't do any sort of multiplying or dividing by a negative, so we stop there. And that's our answer. So I'm going to give you a few more to try. Go ahead and if you'd like to pause and try on your own, that is completely fine with me. I don't mind. Okay, so for the first one, this is not a bad one, even though it has some decimals. All we're going to do is we're going to add 8 to both sides. You end up getting d is greater than 10.2. As long as you remember your rules of decimals, that one's not too bad. So then 5, 6, and 7 tend to get a little bit harder because they involve some negatives, they involve some multiplication and division. So for number 5, we're going to start by dividing both sides by 2. That gives me x is less than or equal to -5. You'll notice I did not divide both sides by a negative, so I don't change anything. On number 6, however, I am dividing both sides by a negative, so it's important that on this one I do change around the inequality sign. It changes to x is greater than or equal to -5. 7 is the same. A lot of people will notice that the answer becomes positive, and so they try not to change it. However, it's important that on this one you do reverse the inequality sign. So I'm going to give you a few more that start off as division. If you want, you can feel free to do these ones on your own also. I don't mind if you just work through them as soon as I'm done writing it and pause. And I'll give you one more. Okay, so the first thing I want you to notice is that these are all different problems. You will get a different answer for each one of these. Believe it or not, they are all different. For number 8, you're going to start by multiplying both sides by 2. In the end, you get x is greater than 20. Number 9, you also multiply both sides by 2. In the end, you get x is greater than negative 20. Make sure that you don't switch around your inequality sign. Then for number 10, you're going to multiply both sides by negative 2. Since you multiplied both sides by a negative, you must switch your inequality sign. It's now less than. We get x is less than 20. And number 11, we're also going to switch around our inequality sign. You get x is less than negative 20. So there's a few more problems that have to do with inequalities. These are multi-step inequalities, but I think most of them will be similar to things that we've done with equations. If you want to start these on your own, feel free to. Go ahead and pause. So for number 11, we're going to start by adding 3 to both sides. That gives me 5x is greater than 15. If I divide both sides by 5, I get x is greater than 3. Similar idea for number 12. I end up getting negative 6y is less than or equal to negative 21. On the second step, I divide both sides by a negative 6. Notice how I divided by a negative. I end up with y is greater than or equal to 21 over 6, which if I reduce it is the same as 7 over 2. So I recommend that once you notice that you get 21 over 6, that you do reduce your fraction. It'll make it easier to deal with. Okay, so for the next two, I would say these are the two hardest ones on here, but make sure you feel sort of okay with them. Just do the best that you can, because they do involve a little bit more with fractions, and some of the fractions are negative. On number 13, there's actually 2 ways to do this. I don't care which way you use. The first way is that you can distribute that negative 1 over 4 and then work out the problem. My preferred way of solving this problem is to multiply both sides by something I know is going to get rid of my fraction. And the thing I know that's going to get rid of negative 1 over 4 is negative 4 over 1. I know that if I multiply both sides by that, my fraction will then be gone. So what's going to happen is negative 4 over 1 times negative 1 over 4 ends up giving me just 1. The p minus 12 remains as p minus 12. On the right-hand side, negative 2 times negative 4 is positive 8. Really, really important that you don't forget to switch your inequality sign. So on the next thing, if you want, you actually don't need to write the 1 times that. That's just an extra step. So if you want, you can skip that. So we're then going to add 12 to both sides, and suddenly we're done with this problem. It is not nearly as horrible as it looks. Alright, last problem. Personally, I think this one's actually a little easier than 13. I think 13 is the hardest. We end up adding 5 to both sides. We will get x over negative 4 is less than or equal to negative 10. I'm going to multiply both sides by negative 4. When I do that, I end up getting x is greater than or equal to 40. So for the next thing, I have one last type of problem, and I'll give you all 3 of them. I would recommend that you try number 14 on your own, and maybe watch what I do for number 16 and 17. It certainly won't hurt you to try them on your own first, but you will notice something weird. And we'll probably go over this type again in class, so if you're confused about it, don't worry too much. So for number 15, I am going to start by adding 2x to both sides. I need to get my variables, both variables, onto one side. The adding 2x is easier because if I add 2x to negative x, it becomes a positive. If you added x to both sides, that would not be wrong. You would still get the right answer. So I end up with 9 is less than 1x, or just x, plus 5. Then I'm going to move over my 5 by subtracting. I end up getting 4 is less than x. In this case, I highly recommend that you always put it in order. It looks much nicer to have it in order. It's my preferred way of doing it, and it's a lot easier to understand. So 4 is less than x is the same thing as x is greater than 4. Make sure that you keep the inequality sign oriented the same way, so it's kind of pointed towards the 4, and the open part of it, like the open mouth part of it, is pointed towards the x. So keep it that way. Okay, 16 and 17. You might notice immediately that something is weird after your first step, because you end up getting 8x minus 4 is greater than or equal to 8x minus 4. When you're working with inequalities, I don't want you just to stop there because you might get a wrong answer if you do. So I'm going to subtract 8x from both sides. I end up getting negative 4 is greater than or equal to negative 4. So now this is really weird. The first thing you have to figure out is this a true statement or a false statement? Is negative 4 greater than or equal to negative 4? Hopefully you said yes. It's not greater than negative 4, but it is equal to. So what we're going to say there is all real numbers, or if you like to write it the lazy way, you can write all reals. Now try 17 on your own, see if you can figure out what's going on that one. So 17 is another weird one. You'll find that when you distribute, you get negative 2x plus 9 is less than negative 2x plus 6. I'm going to add 2x to both sides. You can't just stop and say no solution because you might actually get a true statement. You don't know that until after you do all the work. So in this case, when you add the 2x to both sides, you end up getting 9 is less than 6. So now ask yourself, is 9 less than 6? I really hope that you said no. So this one we say is a no solution. And once again, if you're a little lazy, you don't like writing out all those words, you can write a nice 0 with a line through it that shows that it's a no solution. And we're done.